Good morning, guys. This is the weekend edition here at Mr. C Math Stuff. What I wanted to do today was go ahead and go over the Bucket Brigade lab that we did in class. We had several of you that weren't here. Some of you just might want to review it. But I will go through a basic explanation of our Bucket Brigade lab, what we did to collect our data. We'll go ahead and I'll go over how to create your table and your graph of the data, just as we did in the previous video, to draw your trend line and calculate the equation of that trend line. And then we'll go ahead to your handy dandy TI-83 calculator, and we will calculate the most accurate trend line, or the line of best fit, using the TI-83 calculator. And that should kind of tie everything together nicely for you before we go into our bungee jumping Barbie lab, and I'll be filming an introduction to that for you next. So to get started with, what was the Bucket Brigade? Well, we took our class outside. Fortunately, we had nice weather this time of year. And we filled this nice 5-gallon bucket up halfway with water. Back in the day, when there was a fire in the village, had to get the water from the well or nearest water source to the fire. Everyone would line up and just pass the buckets back and forth. And we did just that. Filled it up halfway, lined up everybody in class going on down, except each group had a recorder held out to record our data. When I said go, I started the timer. The first person picked up the bucket, passed it to the next person all the way on down. When it got to the last person sat down, I stopped the timer. Then we recorded the time, the number of people in line, versus the total time to get the water from one end of the line to the other. After that first trial, I randomly picked out anywhere from 2 to 4 people, just calling out numbers. And those 2 to 4 people stepped out of line, and we did it again with anywhere from 2 to 4 people less. And we continued that process until we had all the way down to just 2 people in the Bucket Brigade and collecting the time. Then we came on back here to class. The recorders for each group shared their data, and the groups put their data together. Now, let's take a look at one of your classmates came up with for their data table and for their trend line that they drew in their graph paper notebook. All right, you can see on this graph they have their title Bucket Brigade at the top, and then in the first column is the number of people. The second column is time. One of the things we talked about in class was that it's kind of reversed. A lot of times in our graphs we have time is on the x-axis and then the other variables on the y. Well, in this case, when we looked at it, it was the number of people that was our independent variable, and the time was the dependent, because if we asked how long it took for the Bucket Brigade to go through to get the water from one end to the other, the answer was it depended on the number of people in line. So that meant the number of people was the independent variable and time was the dependent, because it depended, the length of time depended on the number of people we had in line. So we can see the data that they have going on down there, and then they came down to their graph, and they went ahead and graphed it in their graph paper notebook. They used intervals for time, anywhere from 0 to 45, and they went in intervals of 5 seconds. And then along the x-axis with the number of people, from anywhere up to 23, and they used intervals of 2 to fit it on in, and you can see where they graphed it and drew in their trend line. And from there you could go back to what we did in the last video and calculate the equation of the trend line by picking out the 2 points. It looks like they have this point here and this point here. They could use those 2 points, calculate the slope, use point slope form, and come up with their equation for the trend line. But what we're going to do is a bit different. We're going to take this data that we have here and we're going to put it in the TI-83, and we'll calculate the exact line of best fit. Okay guys, so I came over to my workspace and I have my TI-83 out, and I'm going to go through the steps to go ahead and add my data from my data table. And the first thing I'll do, and I could slide my data right up here where I can see it, and I have my little checklist for you. The first thing is I want to go to Stat and Edit, which would be 1. Okay, now in my L1 and L2 column I can add my X and Y data going on down. So I'm going to go ahead and do that now from my notebook.
13, 11, 8, 6, 4, 3, 2. And once I've entered the L1 for my X, I'm going to come over to my L2, and that I have is 42.1, 31.6, 26.1, 21.9, 18.8, is it? Yes, it is. 14.1, 9.8, 7.6, 5.3, and 3.6. And after I enter the last set of data, I want to make sure I didn't skip any. It comes out evenly, so we are good to go. So that was stat edit, and I went ahead and entered my L1 and L2 data. My next step is to go ahead to stat and calc. And when I come on down on stat calc, I want to go to 4 for the linear regression in the form AX plus B. And I'll write that down. We want to go to 4 linear regression in the form of AX plus B. And when I hit enter and enter again, I go ahead and get my A and my B values. And my A and my B value here, my A would represent my slope and my B would represent my y-intercept. You'll notice right now my R values didn't come up. If that ever happens to you, you need to come down and use the catalog. So I'll go to second catalog, and I'm going to arrow all the way down to diagnostics on, and enter, and enter. And now if I go back to stat calc and enter, I now get my R values, and there's my R value right there. So if the question asks for that for you, you can go ahead and do that. So I have my stat edit, my stat calc. Okay, so he said next I'm going to go to stat plot so I can graph my scatter plot. And the stat plot's right above the y equals, so it would be second y equals. And I want to make sure I'm going to press enter for 1 to make sure my stat plot is turned on. The 1 is blinking now, so I'll press enter. Now the first graph you see here is your scatter plot. That's what I want. I'm going to use my L1 data, my L2 data. And as I get closer to getting my AARP card, you know I need the big symbols to see them. So I will use that first one there. I'm good to go. Once I have all that completed, I can press graph, and I'll get a graph of my scatter plot. Now you notice I only have some of the data in there, so what you might need to do at this time is adjust the window. So I'm going to press window, and it always defaults to your -10 and 10 for your X and Y max and mins in your scales. Well, taking a look at my data and remembering how my classmate had set this up, I have my maximum X is 23, my minimum is a 2. So I'm going to go to my min, X min of 0, because I only need the one quadrant. My X max, I'm going to go to 25, because I always like to go, let me clear that out of there. X min is 0. Arrow down to my X max at 25, because I always want to go a little bit higher than what I have on my data. And then my scale, okay, 1 might be a little much on our graph. I think we used 2. Yes, we did, by hand. Now my Y minimum, again, I'm going to leave as 0. Only need the first quadrant. My Y maximum, it looks like the maximum time was 42.1, so I'm going to put 45, so it's a little bit above that. And the intervals I'm going to set at 5. So we'll count by 5s on that Y. Now when I go to graph, that should clean it up for you. And there's my scatter plot of my data going on down the line. Okay. Now we have our scatter plot of the data. Okay. Under stat plot, I'm also going to put set window. Okay. Now we have the scatter plot. Now we want to go ahead and do our line of best fit on that scatter plot. Okay. To draw in our line of best fit, the equation for our line of best fit, I could go back to where in stat calc where I got my A and B and put it in, but a lot of times for the exact line you're going to have a lot of decimals in there, and I don't want to estimate my line coming in. I don't want to round it, so I want to put in that exact line that they calculated. So I'm going to go to y equals where I would normally put in my equation, and what I'm going to do is press the VARS button and go down to 5 statistics. Okay, so one more time I went to y equals, then I went to my VARS and to statistics. Okay. Then I'm going to arrow over to the EQ. And number 1 is your regression equation, and that's what I want. My regression equation. And we'll go ahead and press enter once 1 is highlighted, or I can press 1. And abracadabra, there you go. It goes ahead and dumps in my regression equation using the A and the B I got from my stat calc. So I don't have to worry about rounding it. It's in there. Now that it's in there, I'll press enter and graph. And now it's going to draw in my line of best fit. So there you have it, guys. That's my line of best fit on my calculator. If I needed to give somebody the equation of the line of best fit, I have it right here in my y equals. If they ask for the R value, I just go to my stat calc and back to my, there you go, linear regression in the form of AX plus B, and I have my R value of 0.997218, and in that 0.99 tells us that it is a strong positive correlation between the number of people and the time that it took for the bucket to get from one end to the other. Okay, so there we have it, guys. We have using the TI-83 to go ahead and calculate the exact line of best fit.
All right, gang, to wrap up the weekend edition here, we went over the bucket brigade lab we did in class, filling our bucket halfway with water, getting it from one end of the class to the other with students lined up, taking a few out every time randomly and plotting the data. And we saw that there was a strong positive correlation between the number of students in line and the length of time it took to get the bucket from one end of the class to the other, going on down. And then we came up with the line of best fit on the calculator using our TI-83, and we're able to graph both the scatter plot and the line of best fit on the calculator. Now, what will we do with that? One of the things I suggest you do, and I suggested to the classes, when you have your notebook and the trend line you drew in, go ahead and try and come up with that equation for the trend line using the 2 points and compare that to the line of best fit that you got on the calculator. It's a good practice for you to go ahead and see how you did there, and you'll have your check built right in, and then you can also check it to the graph you drew, as well as the graph on the calculator. But the last thing we wanted to do in the lab was make a prediction. Now that we have this equation, what's the purpose? Well, we can make a prediction of future outcomes based on the equation that we have. So with the question that I gave the classes, how long would it take to get the water from one end to the other if there were 150 people in line? Well, since we know our x values are the number of people, I could use that equation that I got on the calculator and substitute in 150 for x and solve for y, which would give me the time it would take. Guys, thanks for bearing with me here on the weekend. As you go through, you can go through the process here, go ahead and rewind if you want to try some of the other practice problems that I have posted to make sure you have it all together between finding a trend line, the equation of a trend line by hand, and then going ahead and coming up with your equation for the line of best fit on your TI-83s. Thanks, guys. Enjoy the rest of your week.